G'day folks, and welcome back to Gorman's Shed. Now, after making my last video about rotating magnetic couplings, I realised that there was a couple of things that I should have covered which I didn't, which will be helpful to you when you're building these things, and some people have built them already. And what happens is with some of the wagons that we have, like this is say a typical mainline wagon. It's been converted. We'll come a bit closer. It's been converted, but I've left a little piece of plastic on that normally the tension lock coupling would be mounted to. Now, if you wanted to get a really sort of flash result with your wagons, you'd probably remove that. The thing with removing that is that it's possible that the magnetic coupling can then swing back under the wagon because it's attracted to the wagon weight. This doesn't happen all the time, but it can happen occasionally. And it did happen on this wagon here. This is an Oxford wagon, and it didn't have the protrusion. It's sort of set up for NEM. It didn't have the tension lock protrusion, but I found that the coupling was swinging back towards the wagon weight. So what I've done in this case is the connecting rod that actually holds the coupling into the wagon, I've put a little drop down bar on that, and you can't see it very well on this wagon the way it is. I do have a picture of it, and I'll put that in to the video, and you'll get exactly what I mean. But what I'll do is I'll show you how to make one of those. Alright, we grab a piece of copper wire as we did in the previous video, and it's about 50 millimeters long roughly, and then just put it into the pliers as we were going to do before. However, this time what we're doing is having about 10 millimeters of it sticking out to one side there. So that 10 millimeter section, that short section, we'll just bend that around at a right angle to the other one, to the rest of the wire. That's roughly it. And then we take the other piece of the wire and bend it around the other way until it starts coming around over the top of the bit you just bent, if you can see that. And then the first piece we bent, we'll just bring that around a bit more so that it's around about at a right angle to the top piece. So it looks like that. Okay, so you finish up with this shape here. Now, as I said, there's enough room to slide the coupling in there. So when you get to this stage, what you do is you slide the coupling in probably over this bit and down into the receptacle here, and then close that gap up. And then once you've closed the gap up, you bring your snips back and just see how far down the coupling hangs down this way, and go to the bottom of the coupling and just snip off the excess here. Now what this will do is when it's fitted into the wagon, this bar will stop the coupling from swinging back underneath the wagon. It's a simple fix. I mean, you could make all your couplings that way if you wanted to. It just depends whether you've removed that plastic section I was talking about, or it just depends on how the wagon's set up. If you've got all new wagons, you might have a bit of an issue with the coupling swinging back, but as I say, it doesn't seem to happen on every wagon. It happens occasionally. But this is the workaround if you've got that problem, because if the coupling does swing up underneath and is attracted to the magnet there, when the next wagon comes along from this side to couple, this magnet will be too far away from it and it won't connect. So that's the answer to that one. Now, the other thing we need to talk about is vans with bogies, or coaches if you like, anything with a bogie on it. Now probably your natural inclination is to mount the coupling on the buffer beam for these vans or coaches. With say set track, or even down to say medium radius points, unless you use large radius points, I think you're going to have a problem, and unless you've got large radius curves on your railway, you're going to have a problem with mounting to the buffer beam, because as these vehicles pass through say a typical S formation, you've got the buffer passing each side, because the coaches are so long, or the vans are so long, that's why they have bogies. There's quite a bit of sideways movement when they pass through these sort of S formations. And so if you've got a coupling here and a coupling there, if they have to sort of extend, they'll probably come apart, or the thing will derail or whatever. Been there, done that, tried it. It doesn't work on my railway. So if you look at the setup on a van or a coach, the bogies are actually, I think the wheelbase is probably shorter than a four-wheel wagon or two-axle wagon. So the actual bogies, when they travel through those tight formations, there's very little movement actually between the two bogies together. All the movement is in the swiveling on the shaft for the coach or the wagon. So as far as I'm concerned, the answer is to always use the bogies to fit these couplings onto. And what that means is you've got to work out how do I add this magnetic coupling to a bogie, because it moves and I need to clear the buffer beam and all that sort of thing. So there's a different solution, I suppose, for each brand of coach or wagon to do it. I've got some examples here, and I'll show you. I've got them on the bench here, and I'll show you what I'm doing. Now this is a Lima van that I had converted once before over to the other magnetic system that I was using, and so I've fitted a system to the bogie, and I'll show you what I did, and I'll show you what I'm doing now. So this was the original system, and I've fitted a bit of gal wire here with a T-piece on the end for the coupling to work off. So it was fitted into the end of this bogie, because if you look at the bogie, you've got to deal with axles underneath and all that sort of thing. You've got to stay clear of those, and I could only use short lengths of this particular wire, so I couldn't use the whole length of the bogie. So I'll show you what I'm doing now with the new system, and it'll make more sense. So this is the bogie off the other end. Now what I've done here in this particular case is I've drilled a hole through this center console here, so that I can have the wire running the full length of the bogie, and I've glued it on at each end here with the ultraviolet glue. Now when I first put this wire in, what I did was put a bit of masking tape over this end just to hold it in place. I put it back in the wagon, and that allowed me to check it and see how far I needed to push it back under the wagon, or how far I needed to pull it out to get it in the right position, so that it was close enough to the buffer beam but wasn't sticking out too far. And you'll notice also that on this one I have a bend here just to bring it up to the right height to sort of match up with the buffer beam. So that's the solution in this situation. And this wire here is not copper wire, it's phosphor bronze wire, and it's 25 thou of an inch. I don't know what that equates to in metric, but it's thin, but it's very rigid. And if you use a thicker wire, it's extremely hard to bend. It's very stiff, this stuff, but it's not attracted to a magnet either. So that's the solution for this particular van. And as I said, it'll be different with whatever manufacturer you come to. There's got to be a different way to solve the problem. Yeah, so you can see that on the bend there, it just goes slightly past the buffer beam on the wagon, and then rises up gently at, let's say, 45 degrees. It's probably 30 degrees, so that you get the height. It's sort of coming up close to the middle of the buffer beam where it normally would be mounted. So that's the solution for this particular one. This is a Hornby coach, and again this is a different solution as well. So we'll zoom in a bit so you can have a look at that. Right, with this one we've got a right angle bend here, so that this is brass I've used on this one, brass rod. There's a right angle bend here, so, and it's glued underneath the bogie there. It comes straight up towards the buffer beam, but clearing it, and sits just under the corridor connection. So we've got a bend in it there, and all of this is about clearance and getting it at the right height. So bogies are a bit of mucking around to get things done. You know, as I say, each one requires possibly a different solution. This is a Lima coach. Again, a different approach to it. It's basically the same approach, but you know, you need to adapt to the different types of ways these things are made. So we'll zoom in a bit on this one. Right, with these ones, these Lima coaches, this is what remains of the mounting for the big D-link tension lock couplings they had on them. And so I've got a little narrow piece here, and I've drilled a hole through that to put the brass wire through. So we've got a right angle bend then, and of course this is glued on with ultraviolet glue as well to keep it in position. And then we come forward to clear the buffer beam, do a right angle, and then we've got the coupling at the right height. So that's how that one's been done. And last of all, this is an old mainline brake coach. So we'll zoom in on and see the solution on that one. Here I've left the original mounting plate for the tension lock coupling, although I've taken a couple of lugs off it. And you can see that the brass wire is glued underneath with the ultraviolet glue, and then makes a right angle up again, you know, under the buffer beam and out to the correct height. So that was the solution for that one. So there's a sort of sameness about the solutions, I suppose. It's just that they have to be adapted to suit the different bogies. So you can see, folks, it's horses for courses here. Different solutions required for different manufacturers and setups and so on. Now on my railway, I've got a bit of a compromise going on here. You can see some of my coaches here have magnetic couplings. Now those magnetic couplings are only at one end of the coach. So what I'm doing is I'm setting up the lead coach where it meets the locomotive with the magnetic coupling, and the brake coach with a magnetic coupling on the end, and anything in between is still tension lock. And the reason I've done that is that those coaches I'm using with magnetic couplings will really only service the branch stations, and therefore I can use my shunter's pole to uncouple, you know, run around, all that sort of thing. Makes life easy. Whereas my other coach sets, which are usually 5 coaches long, I've kept or intend to keep tension lock couplings on those, especially the small backmans. If they've got the big couplings, I'll convert them over to the small backmans. And the reason I'm leaving those as they are is because they reside in my sliding fiddle yard, and they need a ramp in there to uncouple them. The magnetic couplings in there are too hard to reach and uncouple. So I've had to sort of strike a balance here between the two systems. So consequently, my locomotives will be set up with a part of a tension lock to connect to coaches. There will be the hook missing in that case, but they will also have the magnetic coupling set into the buffer beam. So it'll be a dual system. So the idea is that the locomotives can pull anything with magnetic couplings or anything with the tension lock coupling. The system, that's how it works on my railway. So I hope this has been a bit more helpful, and certainly with the drop down bar on the wagons, that's a fairly easy solution. So bogies are another story. Okay, I'll leave it with you. Cheers, Gorman.